Okay, today we're going to look at the concept of mathematical modeling. Why do we need to model certain things, a real world application, for example, uh, to the some mathematical modeling? Okay, so the first one is what is mathematical model, and the second one is why do we think that mathematical model is the way moving forward. All right, so basically, if you talk about mathematical modeling, okay, you can imagine it's whatever it is, okay, whatever the condition or the situation that you have that can be translated, you try to make sense of whatever system or whatever situation that you have. Okay, if you want to understand certain particular issues or certain particular problem, for example, okay, how best to do that is you're going to try to reduce all extensive or complex system into a more understandable system. Okay, in a way it's like a language. Okay, in a way you're going to codify, okay, all certain parameters or certain situation and codify it into an understandable language. Okay, in this sense, how to codify the language. Now we are using mathematical language. All right. So that is the concept of modeling certain things into a mathematical condition. Okay, whereby once you translate or once you simplify complex system into mathematical modeling, now you can look more carefully at the parameters that's involved or any variables that involve or any algorithm that are able to really scrutinize what is going on. Okay, that is the concept of understanding a certain thing that you have in mind. Okay, so normally, okay, if you look at the way to move forward, you try to complement both the theory and experiment, put them together, integrate them, and then make it understandable or make it tangible instead of building all your theoretical into your cloud, for example. Now how can you best realize it into a more understandable uh, situation where you can really do something about this. Okay, that's the concept of it. All right, and of course it goes through lots of different branches of knowledge. Okay, now why? Okay, we always have to ask ourselves, if we want to do something, whether it makes sense or not, we always have to ask why we do the things we do. Okay, why mathematical modeling? Why not something different? Why do we even bother to quantify or to translate a difficult scenario in a real world problem into mathematical modeling? Some people even think mathematical modeling is like more making your life more complicated. Okay, but I hope you don't feel that. All right, but since it is a language and not many people can really understand mathematical language that well, okay, that's why some people think having lots of different quantities in a sense of different alien kind of language, for example x y z's and so on, A1, A2, alpha, beta. Okay, but the main intention is to reduce your difficulties into a more quantifiable solutions. All right, so uh, once you get that right, then there is another way to move forward. All right, so we can see some of the mathematical models can be you can use this model, for example, when you want to forecast the weather. Okay, so normally when people talk about weather, they cannot shy away from a dynamical model, okay, where you have certain entities or variables or parameters, in fact, and when you start to look at the initial conditions, okay, what are the initial conditions that reflect to the dynamical system that you have in hand, in which you can forecast the future the future weather, for example. Okay, is quite an extensive uh, extensive branch of application. It is not a straightforward solution. What I mean straightforward, meaning that if let's say you have previous weather data, okay, you cannot simply just use your previous weather data and forecast to the future weather data. It does not work that way. Okay, there are lots of different variables involved. That one is for example, the climate modeling. Okay, but what happen if let's say you have another econometric or more or less financial engineering problem? Okay, in the sense of, let's say you want to forecast a stock market data, okay, and at the same time, how you're going to look at the underlying development of a certain financial series, okay, certain financial series, or how best you can forecast this particular problem. Your problem now is not the same as how you're forecasting the weather. How you forecast the weather, okay, it's completely two different thing. When you want to forecast stock market or index, for example, okay, you can utilize your financial time series, one line of financial time series, but now in the sense how you're going to capture the behavior of this financial time series. Some people use a very tick by tick data. Okay, tick by tick meaning that as huge data as possible, okay, that will give you a better judgment of how your stock market behave in the future. Okay, and they are using another different underlying parameters, or sorry, an underlying behavior to reflect that. Okay, I'm not saying that this is the best method possible ever. For example, you just have one long time series data, then you're good. Okay, I'm not saying that, but at least we are using whatever we have in hand and try to project and evaluate what we can expect in the future behavior. Okay, so there is one another prospect of doing mathematical model in this particular branch. Okay, what about medicine? What about manufacturing or design? Okay, so you can see when you have a when you have a manufacturing, or when you are dealing with a production line, okay, your process of mathematical modeling is completely different. Okay, what it means by that, it means that now you are focusing more on the quality, or maybe on the efficiency of the system, meaning that you have one input, okay, one product, you put the product input, and then you want the product in the output. Okay, and then how efficient your product now would become. Okay, that is another completely different kind of question whatsoever. Okay, and different kind of problems. That means the way you model thing is completely different than the way you model in the previous of my previous two examples. All right, so that is the meaning of one particular mathematical model does not fit the rest or the whole of another problem. In fact, if you look more carefully, for example, the previous climate change example, all right? So, one particular problem when you want to see the change on the weather in this month, for example, the model might be completely different if you have another different inputs, okay, or if you have another different parameters that you need to consider. If let's say right now you have four different parameters that you think can affect your judgment, okay, based on the previous model that you have, who knows, maybe in the next future, or in fact in the next few days, for example, especially right now we are dealing with the COVID-19 issues. Okay, previously you don't have the variable such as this virus, but in this particular month you now have another added value or another added variable that you need to consider inside your mathematical model. That's mean that your model must be dynamic. As best as you can scrutinize all the things that you want inside one model, And then that's why it keeps on changing. Okay, that's why you need to keep on growing and keep on improving your mathematical modeling to fit with your data in hand right now, what you have, and to fit with the original situation where you can reflect as best as you can. Okay, so it does not mean that your once you have the mathematical model and that's it. There's no changes. It's a clear cut. It's a writing set on stone. Okay, it's not like that. All right. Knowledge keeps on expanding and knowledge keep on changing. Okay, so I hope you can cope up, and I'll see you guys in the next lesson.